開始。
For this section, we'll have Mr. Ivan Ma, the MySQL user group lead in Hong Kong. He has over 20 years of experience in enterprise system, infrastructure, and software technologies. He is currently MySQL Principal Solution Engineer, Asia Pacific with Oracle, responsible for pre-sales, consulting, technical education, and product promotions. Mr. Marr is going to talk about the innovation of today with MySQL replication capabilities, including network communication, flow control, and data consistency. The latest Replica set and InnoDB cluster will be explored. Mr. Marr, please.
Hi, good afternoon, everyone. Today, the sections will be about the MySQL HA technologies and also the deployment practice. Sorry for the a bit delay. So let's go start. So this is a general statement, Harper statements. So things about futures. Oracles has to give the statements. So we do not actually contribute to anything that we speak. To promise, okay, something that about futures. So this is the statements, Harper statements. Today, it is the Hong Kong Open Source Conference and day 2. So MySQL user group, we have the 2 sections. The first one, it is the HA practice, and the second one, which will be delivered by Ivan Du, Dou Xiuwen. Now, it is the security best practice. So they are also very important for the enterprise applications, which we rely on the security, and the system must be up and running all time, non-stop. So the agenda for today is firstly to talk about latest update, and we will go direct to the technologies and also as well as the deployment practice. So what's happening to the MySQL over the years? So MySQL has been around with us for 25 years. We do celebrations for this 25th years, MySQL. So since 1995, MySQL was born. And we have the MySQL version from time to time. So since the Sun acquisitions in 2008, we delivered the MySQL 5.1. And in 2010, Oracle acquired Sun Microsystem, and we have the MySQL 5.5, MySQL 5.6, 5.7, and 8.0. And we have been actually doing a lot of innovations over time. So let's look at this. First of all, if you are listening and also checking to YouTube about these sections, so we have the MySQL user group. So you can join anytime. So we will send informations and maybe faculties to have seminars for you. And we can discuss, you can ask. Okay, at each page of the corner, so you can see the QR code. So you scan it, and then you can actually find to join our user group to be the members. So let's look at the version over the time. So firstly, we just give you the intro about MySQL. We have the community. We also have the commercial. So basically, every product, we have a life cycle. So from the developments and thereafter is everywhere available. We call general available is actually so-called GA. And it will go through the process continuous to update and changes. And over time, we have 5 years, there might be another versions coming up. So there should be the support will last for 5. We have the so-called from the commercial support, we have the premier support, which people ask for changes, ask for update, ask for security fix. So it's always be there over the 5 years since GA. And after the 5 years, there is another period called extended support, because over the first up to the 8 years, So security is also really important, like SSL, vulnerability, and people asking, people hacking. So it has to get fixed to the product. So over this time, we have to get first up to 8 years, you still get the fix. So after 8 years, this is the default. Okay, it's the lifecycle support. And there should be another new versions, well mature and stable or up and running. So you can see 5.6, MySQL 5.6 was delivered GA in 2013. So you can consider the 8 years will be upcoming in 2021. And look at the 5.7. So it was GA in 2015. So 5 years, that is this year, 2020. So this year is about 5 years in. So it's going to be the so-called premier support in. So I recommend people look at MySQL 8.0, which is very mature, everyone looking at it and deploy it in all this industry and for critical applications everywhere. So look at the latest update of MySQL. We do have relational database, and people use it to store data as like tables. And on the right-hand side, people also look at some other things, like storing the data using JSON. And JSON is very popular from data exchange, from document analysis, reporting. So we actually embed these kind of features into MySQL as hybrid database. We can tackle problems like OLTP, as well as people using JSON, we call this document store. And there's also on the left-hand side, people also use a lot of mobile applications. And people actually use a lot of GPS, and we call GIS, or somebody called this a spatial database. MySQL has the capability to store data with live locations. So how do you create live location-aware applications? We combine all this into a database and to facilitate people doing the applications, no matter this is analytics, no matter this is the general applications, no matter this is OLTP, or even mobile or location aware. So all this, we also together with recursive CTE or window analytics functions, and of course the basic regarding OLTP tables, index, select statements. So it's built on the platform, which we need reliability. And this is what the topic of these sections. And the HA, high availability regarding redundancy. Okay, when one server is going down, how we tackle the problem and make sure the service is always available. And there is also other aspect. We need to secure the data. And there's also tooling, which we enable the ease of use. MySQL shell, MySQL router, how we back up and no locking, no blocking, how we see visual chart, how we actually use the tools to administrate, to work on the data. So this is a portfolio with MySQL. Look at one of the things before we go direct to the HA. So document store, which is the relational, as well as people look at JSON, or we call this NoSQL. There are people actually look at collections. We, instead of just table, insert, select, update, and delete, but actually collections API. So we deliver the drivers, the connectors, and which maybe people develop application in C, in Java, in Node.js, in Python. So we do provide artists, okay, to get the application up and running and create with the latest and trendy, okay, development methodologies. So like this is just an example using JavaScript. So JavaScript, we create a schema-like database and create the collections, and as well as from the collections to add more data and retrieve the data and find the data with criteria ID equal to something, or even to modify the data, and also to remove the data. And all this we can do in transactions. So this is quite distinction from others kind of database, which MySQL has been doing very well with database OLTP, and now extended to this document store. So here we have the MySQL HA. In the past, people setting up the replication redundancy in replications topology, which can be very manual and taking many steps from setting up, from switching over, or even user management, or materializations for the data from master into the slave. And this is actually, we offer the technical pieces and leaving the space for the developers or DBAs to customize the architecture in the way they build for their own deployment. So DBA has to get on more technical skills. So thereafter, in 2016, we delivered the MySQL InnoDB cluster, which helped a lot to ease the pain for this challenge. And we have the InnoDB cluster, the core part using the group replications. That's the data exchange between the server and the node within the InnoDB cluster. It does the membership changes. So which node is up and running or which node is leaving. So they are managed properly and automatic. And also about consistency, flow control, and how the network partitioning are being handled. We also provide the tools which we call this MySQL shell, which is the interface to administrate the cluster and the components built to this InnoDB cluster. And we also allow this kind of cloning to make sure the first data set, we can actually bring the data and materialize for the second, the third server nodes. So thereafter, we also create another kind of automations, which we call this replica sets. MySQL InnoDB replica set in 2020. We delivered this shell administrative ease of use capabilities to build replication, master, and slave architectures at the fingertips. So InnoDB cluster first. It's a single product, and out of the box, the high availability with scaling features. High availability doesn't mean just only to allow the servers up and running, but as well as to scale at the time we offload the server by grabbing some loadings to other server and adding more servers to relieve the load and cater for the demand from the end users, from the applications. So this is to provide end-to-end solutions with the components for sure, the server, and the core component regarding the group replications to bring data, synchronize among the node 1, node 2, node 3. And there is also the shell on the left-hand side, the shell to administrate, to get status, to provide API into the core component, as well as there is the component called MySQL router, which the applications get transparent access to the backend servers. So the core component, as mentioned, it provides the distributed data among the node 1, node 2, node 3. It allows the fault tolerance when one server is down, data is still always available on the other nodes. And it provides the automatic failover, meaning that one server is done, where's the data go in and out. So it's automatic, amongst the server. They know the heartbeat and they respond to heartbeat. They know each one live or dead. And it allows active update anywhere. And also the memberships management. And there might be the network issues when the time network has partitions. The members has to know and provides the so-called which one is live, which one is dead. So this also managed automatically within this group replication component. So the end game is to allow data to be replicated across all nodes, and we do not want any data loss. So the use case, first of all, no data loss. So data is not just one server, but is redundant on server 1, server 2, and server 3. So the minimum number we recommend is 3. It can be extended to 5, 7, or even 9. And it also provided high available. This high availability in the automatic failover, it allows the servers to respond to update. And when one server is down, even the so-called the primary member, which is writing data, is failed, it can actually route to the other server and record this automatic. So no matter there is the network cannot see it or the server is crashed, so there should be the way to determine which server is up, which server is down. And there is also people look at the use case about rescale, meaning we have the very traditional way of like web applications and on the internet, people access the data and we do not know the expect demand. So it may be so sudden, we have so many users coming in. So we can add more nodes to cater for more user demand. And we also have the flow controls to ensure the data has to be, okay, on all the node, okay, with less lagging. So replication lag can be handled, promisingly using flow control, as well as we support consistency level, which by default, it is eventual or even full consistency, meaning when we update the data, it has to be consistent to all the server nodes. Update on the node 1, node 2, node 3, no matter what. This consistency can be available on all server nodes. So we see that we want no data loss. It has to be automatic failover, and it can be scaled and supporting flow control and also allowing consistency levels to be flexible. We are not just doing like two-dimension A or B, but actually we can define this, okay, by applications. This requires the consistency. This requires performance. It's like three-dimensional. And we also provide the active environments where all those members is doing work. The primaries can do update. Other server can at the same time running query. So we provide this like active components, and so they are all working. So here, the more details about the MySQL router. MySQL routers allow the transparent access to the backend server nodes. And client applications like Java, it might go through the JDBC driver, or we call this connectors, MySQL connector in Java. We define this JDBC URL, and from there, it points to this router is like a proxy. It's like a proxy. So because there are 3 servers, we don't know which servers to connect, but the way is, in a very simple way, we install this router like on the same host with the applications. So the Apache, the Tomcat, okay, the server has the routers together. So the Tomcat application just connects to the local host, and this direct connects to the backend servers. So no matter the server at the backend, node 1 is down or up, so it's all transparent to the router, and the application is able to access to router and transfer the data to the right server. So this is what we call this transparent client connections routing. And it allows load balancing because we have 3 servers. Likely, it may be the server 1 to respond, maybe the server 2 to respond. So it actually provides you the load balancing. And as well as when one fails, this can be the failover, and we don't need to do these like configurations. When we add one more node, or we move the nodes, or due to the reasons to maintain the server, we need to shut down. All these configuration changes, we hide it. We do this transparent to the applications. So as well as this router is status design, we can install A, B, C, D, 1, 2, 3, 4 server. So we can have 1 router, 2 router, 3 router, 4 routers. So this is easy to use. And it's also integrated to the part of InnoDB cluster, as well as the next part, we talk about the replica sets. So here we can see on the left, we have the InnoDB cluster. On the right, we also to use the shell to configure the master and slave. We call this replica set, and routers will know which one is master, which one is the slave. So replica set is fully integrated to router, and also shell provides the ability to configure this replica set. And it allows to switch over with the API, and it allows more servers to add, likes to scale out, and we add more slaves. So ease of use, you can see from this simple script. To build a InnoDB cluster, this is kind of the script. Connects to the server, create the cluster, and configure the instance, and add more instance, add instance, add instance. And the same way we build the replica set, create the replica set on the right-hand side, and configures the replica set instance and add more nodes. So it is quite similar, and as well as we start the router and configure the router. So they are very simple, and this provides the ease of use. So back to the InnoDB cluster a little bit more. With the InnoDB cluster architecture, as mentioned earlier, we need 3 nodes as minimum. 3 nodes as minimum in a sense. Why we need 3 nodes? Because there should be some way to determine the up or down. If just 2 nodes, when the network is split, no one can tell you which server is up or down. With 3, we have the majority. If 2 actually can see each other from the heartbeat, 2 will be live, and 1 is down. So 3 is a minimum, and has to be the odd numbers to provide the so-called majority. So here is a demo. I'm going to show you pretty much a good demo with this. Here, look at this. This is the applications at the back. We have 3 nodes MySQL server running with InnoDB cluster. Node 1, Node 2, Node 3. So the money is sending in and out. And we can see the transactions, the red bar right here is talking about data is updating, is being updated. And also data is being read from other 2 nodes. So what actually the command at the back is to show you. Okay, we have the Node 1, Node 2, and Node 3 up and running, and they are online. And what we do is in here, how about when a server is down, I'm going to shut down or even to crash a server. So this just to stop a server, which is the Node 1, which is now, it is red color. So when I bring the server down, what happened? It's offline. So what happened is offline, the application can still continues to work. You can see the data and applications still go in. So application and users will be happy. Even a server is down, we still have the servers up and running. What next? I bring back the data. I bring back the server up and running, the Node 1. What happened? So the data has to catch up because more data will be updated on the rest of the 2 nodes, right? So when I bring back this Node 1, so what happened to this? Basically, you can see the Node 1 has the data. And then what I'm doing at this moment, we connect to the so-called middleware, the MySQL router, and it tell me it is connected to the second node 3320, and which is the red color. And what's right now, I'm going to the MySQL shell. I set the primary instance to the machine, which is the Node 1. So what happens when I do this? See, the chart is telling us the red is shifting from the seconds to the first. So the first is the primary. So you can see this is quite easy, or even to scale up. So your application is free and is happy with performance scale out with the automatic failover, and we can bring back data easily. So the end user, the end result is they are happy. So with the deployments, what we like to see is a single data center. People consider one data center, they have redundancy. As the redundancy minimum, we have 3 nodes. And the applications may also be redundant, 2, 3, 4, 5, and each one pair up with the MySQL router. And the applications connect to the routers just like local hosts, and this can connect back to the backend server. And there are tooling, there are monitors which can actually get visual chart. People also look at how we build 2 data center or cascade to more, even on cloud. So when we build this, basically the InnoDB cluster can be extended to the next data center where we build the replication and transport the data from one site to another site. People will do async because it can be the regional, which data has latencies to reach the other side because it's just like long distance. So what we can actually do as alternative, people may push the router as external rather than to put onto the local host. And people will expect to get some load balancing capability between the applications as well as the router. So the applications, via the load balancers, can come to the one of those routers, and the router will know the backend servers. And there are illustrations. This is illustrations with like physical machines deployment where cluster can put into multiple InnoDB cluster. Like we have 4 physical machines. We may pair up 3 nodes InnoDB cluster on 3 machines, and the other 3 machines with the second InnoDB cluster. Another set may be another set of 3 machines. So this is like virtualizations in a game. So as a whole, you can see this, we have the MySQL availability sections. We talk about how replications can do better. We have the asynchronous replications. We have semi-sync in the past. We actually built InnoDB clusters together with the replica set. And this actually is the core component with replications, router, and shell. And the deployment practice, we talk about 1 DC with minimum 3 nodes, and as well as it can be extended to 3 nodes, 9 nodes. So this is also about the data center, not just one data center can extend, and we may use the load balancers to extend the applications into the router by putting the load balancer between the 2. Okay. So that's about today MySQL high availability sections. I hope you get pretty much the overall update about the HA technology, and we can meet in the Facebook user group, and in the futures we can actually talk in more details. Yeah, thanks. Thank you. Bye-bye.
Thank you, Mr. Mar, for such a wonderful sharing. I believe the audience have known more about MySQL and also the replica set and InnoDB cluster. Thank you.